Whenever China starts building, the world stops to watch. Every new project seems designed not just to work, but to dominate headlines larger, faster, and more daring than what any other nation would even try. From ports that run without people to highways hidden beneath the sea, each construction rewrites what engineers thought was possible. And when you compare this pace with what is happening elsewhere, it becomes clear why some countries now look frozen in time. From far away, the structure ahead looks fragile, like a thin silver line drawn across the ocean. But behind that beauty is one of the most extreme engineering feats ever made. So stay with us, because next you'll see the 8 largest projects in China. But before we begin, don't forget to like and subscribe to our channel. 8th. The Hong Kong-Zhuhai-Macau Bridge. Calling this just a bridge would be an insult to its scale. What stands here is a hybrid geonta system where bridge, tunnel, and artificial islands merge into one continuous crossing. Stretching about 34 miles from end to end, it is the longest sea crossing project of its kind on the planet. What used to mean hours on a ferry or a massive road detour is now a fast, direct trip linking 3 major cities in under an hour. To make this possible, engineers had to fight the ocean itself. In the heart of the Pearl River Delta, where tides, waves, and typhoons constantly clash, they built 2 artificial islands. These islands act like stepping stones for cars, one where the bridge sinks beneath the sea, and another where it rises back into daylight. To create each island, workers drove more than 100 enormous steel cylinders deep into the seabed. Each one was packed with rock and sand until it became strong enough to hold roads, tunnels, and heavy structures. Doing this in calm water would already be a nightmare. Doing it in violent seas, where the wind can change in seconds, meant stabilizing massive structures while nature tried to tear them apart. Between these 2 islands lies the most breathtaking part of the entire project, an underwater tunnel about 4.2 miles long. It was built like a colossal puzzle beneath the sea. Each segment was constructed on land, sealed at both ends, and floated out like a giant barge. Each concrete block was around 590 feet long, 125 feet wide, and 36 feet tall, weighing close to 80,000 tons. Once in position, they were slowly lowered into a trench on the ocean floor and locked together with watertight joints, while divers and surveyors checked every inch of alignment. Picture pushing massive concrete train cars underwater until they connect perfectly again, and again until the 2 islands finally met. When the final seal was closed, a hidden highway was ready to send cars beneath some of Asia's busiest shipping routes. Above the water, the main bridge runs for more than 18 miles, held up by towering pylons and elegant cables. Every detail had to satisfy 2 opposite needs. It had to stand high enough for cargo ships to pass below, but sleek enough not to fight the wind like a giant sail during storms. The entire system, bridges, tunnel, and access roads, follows one single standard of safety: lighting, drainage, and emergency exits, so drivers never feel a change of structure. From behind the wheel, it feels like one endless road floating across the sea. A dream of this size comes with a massive price. The total cost reached about $18.8 billion, covering everything from the main bridge and tunnel to the roads connecting Hong Kong, Zhuhai, and Macau. And the human effort behind it was just as monumental. At its peak, more than 14,000 workers and about 300 vessels were at sea at the same time, driving piles, transporting tunnel segments, and lifting bridge parts into place. They worked to the rhythm of the ocean, moving fast when the weather was calm and locking everything down when a typhoon warning appeared. This tireless cycle of stopping and starting went on for years until, finally, in October 2018, the bridge was opened to traffic. 7th. Raffles City, Chongqing. Raffles City in Chongqing does not just rise high, it floats over the skyline like a fleet of ships sailing through the clouds. Built at the meeting point of 2 great rivers, 8 gleaming towers rise from the tip of the Chongqing Peninsula, and crossing 4 of them is something the world had never seen before. A horizontal skyscraper called the Crystal, nearly 1,000 feet long and set about 820 feet above the ground. It is far more than a simple skybridge. Inside it are gardens, restaurants, a pool, lounges, and an observation deck that lets visitors walk between the towers without ever touching the streets below. Seen from afar, it looks like a futuristic spacecraft hovering over the city, and that was completely intentional. The site was not an easy place to build. It sits exactly where the Yangtze and Jilin rivers meet, one of the windiest, steepest, and busiest areas in the region. Below, there is constant traffic of boats and roads full of cars and streetcars. The architects wanted the complex to look like a harbor in the sky, each tower like a mast and the crystal like the hull of a ship. 2 of the towers reach about 1,160 feet, while the other 6 rise to around 820 feet. The crystal spans the 4 mid-height towers, while smaller sky bridges connect it to the taller pair, creating a network of suspended paths over the city. From the riverbanks, it truly looks like a massive ship anchored in the clouds. Making it stand firm in such an exposed location required some of the most advanced engineering China had ever attempted. The foundation of each tower had to resist constant winds, temperature changes, and even the slow shifting of the riverbanks below. The crystal itself was treated as a separate building, an enormous enclosed structure with its own steel skeleton, walls, and safety systems, all integrated into the towers. Just the glass and aluminum cladding required thousands of panels, each carefully shaped and angled so the surface would look smooth and continuous, both to those looking up from the street and to those standing inches from the windows. But what really amazes is how it was built. The crystal was not assembled in a single piece. It was put together like a puzzle of 9 huge sections. 4 of them were built directly on top of the towers, as if workers were building a ship on rooftops. 3 others were assembled on the ground, each the size of a small building, and then slowly lifted hundreds of feet into the air by special cranes. Each lift had to coincide with calm weather, because a sudden gust could swing the piece like a pendulum. Once in place, teams guided it with millimeter precision until it fit perfectly. At its peak, the site buzzed with more than 6,000 workers. Welders, crane operators, and engineers moved in careful rhythm, working through rain, fog, and the unpredictable winds of the rivers. The cost was as bold as the project itself, about $4.8 billion for the entire complex. That included not only the towers and the crystal, but also a massive mall at the base. Offices, apartments, a hotel, and all the bridges and walkways that tie everything together. When Raffles City Chongqing opened at the end of 2019, the city turned out in force. The mall drew crowds in the hundreds of thousands, and the crystal's observation deck became an instant icon, offering a glass floor view exactly over the point where the 2 rivers meet. 6th. Shanghai Yongshan Deepwater Port Automated Terminal Phase 4. Out in the open sea. South of Shanghai, engineers did something that seems impossible. They created a new coastline and then placed a working port on top of it. Phase 4 of the Yongshan Deepwater Port occupies about 23.7 million square feet of artificial land and stretches for roughly 1.5 miles of shoreline. From the start, it was designed for the largest cargo ships in the world, those floating cities that carry thousands of containers stacked like Lego bricks. Test operations began on December 10, 2017, and since then the port has been rewriting the rules of global maritime transport. Before it could move a single container, there had to be land where there had only been water. Teams began by reinforcing the seafloor and piling up rock and sand to form new islands. Huge concrete boxes called caissons were put in place and filled to lock the coastline against waves and tides. Once the ground was ready, workers organized the site as if it were a giant circuit board, burying power cables, data lines, and guidance markers for driverless trucks. Rails for the cranes were embedded in the floor, and at the center of everything, a tall glass control tower was built, functioning more like a computer lab than a port office. The berths were dredged to about 51 feet deep, giving the largest ships on Earth enough space to dock head-on. Then came the brute force, the machines that make the port move. Along the waterfront, 21 giant cranes now rise like red skeletons, each capable of lifting a 40-ton container in a single move. Behind them, 108 automated yard cranes organize containers into tall, neat stacks almost 80 feet high. And moving among them are about 125 autonomous vehicles, flat electric platforms that run between cranes and yards, carrying containers back and forth 24 hours a day. It looks like a dance of robots moving in perfect rhythm, never stopping to eat or rest. But the real magic is in the system that commands everything. Instead of buying foreign software, Shanghai created its own intelligent control brain, a program that decides exactly where each container goes, when it moves, and which machine should handle it. It updates itself constantly, every few seconds, as ships arrive, trucks line up, or a crane slows down. That is why the yard can go dark at night. No floodlights are needed. Sensors, lasers, and algorithms guide each machine silently and precisely, even in fog or rain. Building so much technology was not cheap. The terminal cost about $1.95 billion, but that money created the largest fully automated container port in the world. It also helped Shanghai keep its title as the busiest port on the planet. 5th. 3. Gorges Dam Shiplift. The shiplift at the Three Gorges Dam is one of the most impressive machines ever built for a river. It works like a vertical elevator for vessels, raising or lowering about 371 feet in a single move. That means a 3,000-ton ship, which once had to slowly pass through 5 different locks, now makes the trip in about half an hour. The heart of the system is a huge steel box, or chamber, that carries both the ship and a layer of water. This chamber slides between 4 concrete towers built on the left side of the dam. It is about 394 feet long, 59 feet wide, and 11.5 feet deep, large enough for river cruise ships and heavy cargo vessels that sail the Yangtze every day. When it moves, the lift raises or lowers about 37,500 tons in total, counting the water, the structure, and the counterweights. No other shiplift on Earth handles a load that large. To build it, engineers had to turn a steep cliff into a gigantic machine room. They began by cutting deep into the rock and pouring massive foundations for the 4 main towers. Each tower had to be anchored directly into bedrock to support the weight and vibration of the moving chamber. While the concrete towers rose, steelworkers built the enormous ship chamber in sections at ground level. Each piece was shaped like a rigid metal box, thick enough to remain perfectly straight even with waves and a vessel moving inside. Then the pieces were slid into the towers and welded together with such precision that the seams are almost invisible. The next step was installing the system that makes the chamber move. Along each tower, workers mounted long vertical racks of steel teeth, paired with motor-driven pinions that climb up and down those teeth like gears on a rail. Dozens of electric motors drive the system, and huge counterweights hang inside the towers to balance the mass of the chamber. This means the motors do not have to lift the entire weight by themselves, they only control the motion. Engineers chose this rakan pinion system because the water levels above and below the dam rise and fall dramatically throughout the year. Traditional cable elevators would be too risky, but this system keeps working no matter how the river changes. Before any ship could use the lift, the team tested everything again and again. They ran the empty chamber to check gears, lasers, and brakes. Then they filled it with water and slowly practiced full lifts, watching sensors that measured stress on every bolt, beam, and bearing. When the first cargo ship went up in July 2016, the test was perfect. On September 18th of that year, the lift was officially opened for limited operation, instantly reducing a process that once took hours to just minutes. Today, hundreds of ships pass through it every week, as if it had always been part of the river. The ship lift is part of the much larger Three Gorges project, which cost about $31.8 billion in total. The lift was one of the last and most expensive additions to complete the entire dam system. At the peak of construction, nearly 40,000 workers were spread across the whole dam complex. Fourth, Beijing Daxing International Airport. Seen from above, Beijing Daxing International Airport looks like a golden starfish spreading across the plains south of the city. But when you are inside, it feels more like an endless, flowing hallbright, open, and incredibly smooth. The main terminal alone covers about 7.5 million square feet, making it one of the largest single buildings on Earth. In total, the airport occupies roughly 18 square miles and sits about 29 miles from downtown Beijing. It was built to relieve the crushing traffic of the city's old airport and to unite air, rail, and road transport into one great connected hub. The magic is in the layout. Most airports make you walk through long, tiring corridors, but Daxing was designed to reduce that distance almost to zero. The entire building opens from a central hall under a wavy, ribbed roof that seems alive with daylight. The great steel ribs of the roof are not just elegant, they do the heavy work of spanning huge distances without filling the floor with columns. Skylights flood the hall with soft, natural light, and the multi-level plan keeps domestic and international passengers moving separately, without confusion. Achieving something so graceful required construction on a truly wild scale. Work began at the end of 2014 and, in just 5 years, the core of the project was complete. That is almost unbelievable for something so vast. Before a single column could rise, teams spent months strengthening the soft ground under the runways and taxiway. Then came the steel. Hundreds of giant pieces were lifted and joined in a choreography that let the roof assemble like a massive puzzle. The schedule had no slack. Pour the cores, raise the trusses, close the roof, and start the endless web of baggage systems, wiring, and security equipment hidden below. Everything had to move in perfect rhythm, or the entire plan would fall behind. At its peak, more than 40,000 people worked on the site every day. Steel workers bolted the roof sections together, while concrete crews shaped the halls below. Electricians pulled miles of cables, while other teams installed glass panels, floors, and lights. Hidden beneath the surface is one of Daxing's best ideas: a huge ground transport hub built directly under the terminal. With about 860,000 square feet, it connects high-speed trains, subways, and regional lines straight into the heart of the airport. You can land, pick up your bags, go down an escalator, and be on a fast train to the city in just minutes. Of course, all of this came with an enormous price. Building the airport itself, runways, terminal, and aviation systems cost about $17 billion. But when you add the expressways, railways, and urban infrastructure built to support it, the total rises to about $63 billion. Third, Ping and Finance Center. The Ping and Finance Center is not just a skyscraper, it is an engineering challenge turned into art. Rising about 1,965 feet above Shenzhen, it is the 5th tallest building in the world, and the tallest in southern China. From the outside, it looks simple, a single elegant tower tapering into the clouds. But everything about it was designed to face the problems that come with such height: wind, weight, lightning, and time. 8 giant columns frame the tower, all connected to a thick concrete core at the center. Between them, massive steel trusses act like muscles, linking the core to the outer structure so the whole building moves as one. That pointed, aerodynamic shape is not just beautiful, it cuts wind pressure by almost a third, preventing the tower from swaying when typhoons hit the coast. The hardest work began before a single floor was built. The site sits next to an active subway line, so teams had to dig a deep foundation pit while making sure trains kept running safely beside it. They built thick retaining walls, drove huge piles into the ground, and poured a reinforced concrete base, strong enough to support the weight of a vertical city. Only after months of underground work could the team begin to rise. When that happened, the pace was incredible. Each new floor was finished in about 3 or 4 days. Week after week, Shenzhen's skyline changed before people's eyes. The tower's 8 outer columns are shaped like chevrons, and they reveal the building's secret. Inside, the central core provides most of the stiffness, while those outer columns handle wind and gravity loads. 4 sets of steel outriggers horizontal braces hidden at different levels tie everything together. It is like connecting the center and the rim of a wheel with spokes. This system allows wide-open floors with no internal columns in the way, something essential for large trading floors and tech companies that rent space there. Then comes the skin, the part that gives Ping and its bright silver look. Instead of aluminum, builders used marine-grade stainless steel, about 1,700 metric tons of it. Ordinary metal would corrode in Shenzhen's salty, humid air, but this alloy stays sharp and shiny for decades. Each panel was custom-made and installed with surgical precision, aligned so the tower's vertical ribs stay perfectly straight from the ground to the top. The site itself was a city within a city. At its peak, more than 15,000 workers filled the area. Core crews pouring concrete, steel teams bolting the mega columns, welders working on the trusses, facade installers hoisting panels hundreds of feet into the air, and electricians wiring the massive podium that connects to the subway. Because Shenzhen is often struck by lightning, the design had to think ahead. Instead of relying only on ordinary lightning rods, the stainless steel columns also act as a protective cage, safely conducting electrical discharges down to the ground. A tower of this size does not come cheap. The entire complex, 2 towers, podium, and everything else cost about 13.5 billion yuan, roughly $2.1 billion. Second, Shanghai Tower. Shanghai Tower does not just rise into the clouds, it seems to twist through them. At about 2,073 feet tall, in Shanghai's Pudong district, it is the tallest building in China and one of the tallest on Earth. Finished at the end of 2014 and opened the following year, it stands beside 2 other icons, the Jin Mao Tower and the bottle opener-shaped World Financial Center, forming a trio on the skyline that looks carved by the wind itself. That twisted form is not just for show. Each floor turns slightly compared to the one below, totaling a rotation of about 120 degrees from ground to top. This slow spiral has a powerful purpose, calming the violent winds that hit skyscrapers of this height. In wind tunnel tests, engineers found that this curved twist cut wind pressure by about 24%. That aerodynamic advantage allowed lighter materials, reduced sway, and saved around $50 million in construction. What hides beneath that glass skin is even more fascinating. Shanghai Tower is actually 2 buildings in one. Inside is a tall, straight core of concrete and steel that supports the structure. Outside, a transparent facade wraps around everything, creating a kind of giant greenhouse that rises in a spiral. Between the 2 walls is a calm transition zone filled with hanging gardens, cafes, and public spaces. The air trapped between the layers helps insulate the interior, keeping temperatures more stable and reducing the energy needed for heating and cooling. These atriums also cut noise and give workers, guests, and visitors something rare: green, sunlit spaces hundreds of feet in the air. But before any of that could rise, builders had to anchor the tower to the ground. And that meant solving one of Shanghai's biggest challenges: the soft soil of the river delta. To support such a heavy structure, engineers poured one of the largest concrete foundations ever made in China, using about 80,000 cubic yards of concrete in a single continuous pour that lasted more than 2 days. Beneath that slab are more than 1,079 reinforced concrete and steel piles, each driven about 250 feet deep to reach firm layers below the soft surface soil. That invisible foundation is the silent muscle that keeps the tower stable during typhoons and tremors. Inside, the building is organized like a series of stacked communities. It is divided into zones, each with its own lobby, gardens, and elevators. Offices occupy the lower parts. Luxury hotels and observation decks sit closer to the top, and mechanical systems are arranged between these areas. This design shortens elevator trips and makes the huge building easier to move through. At full capacity, about 16,000 people can live, work, and visit the tower at the same time. A vertical city with restaurants, lounges, and some of the best views in Asia. Even the elevators break records. Using a special system from Mitsubishi, they climb at about 46 miles per hour, fast enough to make ears pop. In less than a minute, Passengers reach observation decks more than 1,800 feet above the streets, where Shanghai spreads out like a glowing map of light. And to make sure no one feels dizzy on windy days, engineers installed a huge tuned mass damper, a swinging weight of about 1,000 tons that moves slightly to balance the building's sway. It is like a hidden pendulum keeping the tower calm when the wind pushes. All that innovation came at a price to match the scale. The entire project cost about $2.4 billion, financed largely by the city itself. First, Shenzhen-Zhongshan Link. It is hard to imagine the Shenzhen-Zhongshan Link until you understand what it really is. A chain of about 15 miles of bridges, tunnels, and artificial islands stretched across the open sea. It connects to major cities across the Pearl River Delta, a region once known for long detours and endless traffic. Now, cars make the same trip in about 30 minutes. The link opened on June 30, 2024, and is already being called one of the boldest overwater construction projects ever built. More than 15,000 workers faced brutal typhoons, extreme heat, and seabed mud that behaved like quicksand. It was not just a bridge, it was a battle against nature. Divers, welders, crane operators, and engineers worked together day and night, racing against the weather to make the dream real. The structure has 3 parts: bridges at each end, a long undersea tunnel in the middle, and 2 artificial islands that tie everything together. These islands act like lungs, helping the link breathe. Workers built them by driving huge steel walls into the seabed, pumping the water out, and filling the space with layers of rock and sand until new land rose from the waves. These artificial islands house the tunnel entrances, ventilation shafts, and safety systems that keep the entire highway running smoothly. Then came the hardest part, the tunnel. It is made of 32 giant concrete pieces, each about 540 feet long, up to 180 feet wide, and around 36 feet tall. Each block weighs about 80,000 tons, the same as a modern warship. Teams floated the blocks out to sea, guided them into exact position using tugboats and GPS, and slowly lowered them into a trench dug in the seabed. Divers worked at depths of more than 100 feet, helping align each piece before sealing it to the next with watertight joints. When the final joint closed, the tunnel became a continuous highway with 4 lanes in each direction, the longest underwater road of its kind in the world. Inside the tunnel, everything is smart. Cameras, sensors, and colored lights watch every car and adjust traffic in real time. There are ventilation ducts, emergency passages, and even a hidden interchange below, so cars can change routes without coming up to the surface. Above the water stands the Lingdanyang Bridge, which crosses major shipping lanes. Its steel deck stretches more than 5,400 feet between 2 towers that rise to nearly 900 feet tall. The clearance under it is about 250 feet, giving enough space for even the largest container ships and cruise liners in the world to pass. Before any steel was assembled, engineers tested models in wind tunnels with near-hurricane speeds of almost 190 miles per hour to make sure the bridge would survive the strongest storms. After approval, giant cranes lifted each deck segment, welders sealed the joints, and paving teams finished the surface with a special epoxy asphalt made to resist salt, sea spray, and heat. All of this cost about $6.15 billion and took 7 years to complete. Thank you for watching. Now check out the videos appearing on the screen for more unbelievable stories.